All right, so using trig to find area. On your test, I'm going to give you a regular polygon. That is an octagon. All right? And we're going to go back and try and figure out what is the only way to find the area of an octagon. Close. Baker points to the board. One half the apothem times the perimeter. Now, you probably want to draw this. So, we got an octagon, and we know that one side of that octagon is 10 units long. Now, with just the information that we're given, what are we able to fill out in the formula? The perimeter. All right, it is an octagon. One side of that octagon is 10 units long, so all 8 sides add up to 80. So right now I know that 1/2 the apothem times the perimeter, that's what the equation looks like. The perimeter of that shape is 80. So I'm only looking for the value of the apothem. I'm trying to figure out how long is the apothem. Now, we went through a process, and you were supposed to do this on your quiz. Most of you were successful. If we have an 8-sided figure, that means there is 8 congruent central angles in that figure. So if I take 360 degrees and I divide it by 8, how big is each central angle? 45 degrees. Now, there is a very special property. What does an apothem do to a central angle? It cuts it in half. So how big is this one angle right here if I cut 45 degrees in half? 22.5. Now, an apothem cuts a central angle in half. An apothem also cuts a side length in half. So if this entire side length is 10, then it creates 2 5-unit long pieces, which is the bottom of this large triangle I've drawn over here. All right? So I have a right triangle created by an apothem, a radius, and a side length. Is there anything special that happens in a 22.5, 47.5, 90 right triangle? No. So the only way to solve for a missing value is to use your old friend trigonometry. Hence the topic, using trigonometry to find the area of a shape. So I'm looking to solve for A. What is the only trigonometric function that does not use a hypotenuse? Tangent. So if I calculate the tangent of 22.5 degrees, it is equal to opposite over adjacent. What do you do when there's a variable on the denominator of your function? Tangent 22.5 and A switch locations. So A is equal to 5 divided by the tangent of 22.5. And guess what? We have just solved for the length of A. How long is A?
12.0711.
So I would recommend just taking this value and putting it right here for your apothem. 1/2 the apothem times the perimeter. The reason I don't recommend calculating that and rounding it is because when you round it, it will compound your rounding errors, and it says, it might say leave your answer to the nearest 10. So now I'm going to use my formula, 1/2 the apothem times the perimeter to calculate the area of this shape. 1/2 times the apothem times the perimeter. 482.8. 42.8. .8 units squared. How fun is that? And there is no other way to do it. There's no other way to do it. I'm not going to say that because that's not always true. So you have to draw your triangle, and then you have to evaluate which function is correct. Guys, how many points in this process is there an opportunity to make a small mistake? A lot of them. So what will never change, ever, is that every octagon has a 22.5, 90, 47.5 right triangle created by the apothem and the radius. That will never change. So let's practice that one more time. All right? It says, here is an octagon, right? And to find that central angle, 360 divided by 8, cut 45 degrees in half, which makes your 22.5 degree angle right here. All right, we're trying to calculate our apothem. This is a radius. And if I cut that side length 5 in half, you have to remember to do that. How big is this piece on your triangle?
2.5.
So if I go back to solve for A, the tangent of 22.5 is equal to the opposite value over the adjacent value. And what happens in that scenario? Your apothem is equal to 2.5 divided by tangent 22.5. What is the only other value that I need to calculate the area of this shape? Perimeter. Well, one side is 5, and it has how many sides? So the perimeter is 40. So 1/2 times the apothem times the perimeter. Anybody do it?
120.7 minutes.
Remember that passage I read you guys yesterday? It's going to take a little bit of effort. This is the hardest scenario you will ever run into. Right now. And then I'm going to throw this at you again when we do solids to find the volume of a hexagonal prism, or to find the surface area of a hexagonal pyramid. This is not going to go away. All right? So this is the shape that you will see on your test. A pentagon. So I'm giving you the pentagon, right? Every triangle created by the apothem and the radius of every pentagon will be similar. So I'm going through this process now so you have a little bit more comfort with it on Thursday. So a pentagon has 5 sides. What is the measure of a central angle in a pentagon? 360 divided by 5. 72. So when you draw a triangle everybody can see, hey, your apothem is already 10 units long. That's awesome. What is the only thing that you're missing? Well, I know this. I'm just missing the perimeter value. Perimeter. All the way around the shape. So if I cut this 72 degree central angle in half, what is the angle formed at the vertex of the triangle? 36. And you have x down there. Now, it is, don't be a baker. What does X represent? No. Half of the side length. That represents this value right here. Half of the side length. That's the huge mistake I made earlier. So right now, my X value will be calculating one portion or 1/10 of that pentagon. So how do I calculate X?
The tangent of 36 equals X over 10.
What happens when there's a number on the bottom? So X is equal to 10 tangent 36. Right? Now how many of those pieces are there?
10.
There's 10 of those pieces. So I can say that my perimeter is equal to 10 tangent 36 times 10 of those pieces. Or you can calculate it and double it and then make it by 5. Does that kind of make sense? A lot of different ways to do that. I think multiplying it by 10 is the quickest way to do it, but most often the most confusing way to do it. So once you calculate 10 tangent 36, 7.26543. That represents one small portion of that. So you can double it and get the whole side length. So one side length is 14.53, and how many sides does that shape have? So the perimeter of that shape is 72.6543. So 1/2 times the apothem times the perimeter. The perimeter of that shape is 363.2 or 363.3. Right? And I told you guys 1/2 times the apothem times the perimeter. Same thing. No matter how you use your calculator or how much you're good with mental math. It was 363.3. But what is the main thing I want you guys to take away from this? What is the triangle created inside of a pentagon to calculate the area? It's at 36, 54, 90 triangle. Right? Because on your test, you're going to have to use this triangle with the apothem, the radius, and the side length to calculate the area of that triangle. No matter how big or small that pentagon is, it creates a 36, 54, 90 right triangle inside of it. And you will have to use it on your test. But I thought I was giving you guys a gift today. Doesn't feel like it, does it? Welcome to the Thunderdome. Huh? Do you see the difference between these two problems? I gave you the apothem, right? So all you have to do is solve for perimeter. Now I'm giving you a radius. What does that mean? You have to solve for the apothem and you have to solve for the perimeter. I'm about to flex all over you. You ready? Well, this is about as PreAp as it gets. So what is the formula to calculate the area of a regular pentagon? Are you ready? Okay. What kind of triangle is created in a pentagon?
36.
Inside of this triangle we have a 72-degree central angle, which cuts in half and makes a 36-degree angle here, a 54-degree angle here. You have an apothem measurement, half of a side length, and a radius. Thank God for YouTube. Alright? So how are you going to go about solving for A and then S? It is impossible to use tangent because you have two variables there, A and S. Sine of
36.
Okay, so we do the sine of 36 is equal to opposite over hypotenuse. What happens when there's a number on the bottom? So S is equal to 10 sine 36. Whoa. S is equal to 10 sine 36. So that represents the value from here to here. How many of those values make up the whole perimeter?
10.
So I need 10 of those. Now I have a perimeter. Oh, my bad. Now I need to go find my apothem. You're saying cosine of 36? A is equal to
10 cosine 36.
So, so the area of this shape is equal to what half? 10 cosine 36 times 10 sine 36 times 10. There is no other way to do it. You know what? In about 5 minutes, all this will be useless.
What?
Oh, sorry, cat's out of bed. You gotta earn the gift before I give it to you. And 5 years ago, I was useless. Ready? Uh-oh. 0.5 times 10 cosine 36 times 10 sine 36 times 10. 237.7. 237.8. Yeah? I mean, that's easy. Child's play. That number is very important. I'm going to make sure I write it down. 237.8. Well, 237.764. Are you ready for your present?
Yes.
Oh, dear God, I'm ready. All right. What is every polygon made of? Triangles. Every single polygon is made of triangles. Every single regular polygon is made of equal triangles. So there is this sate that created using trig to find the area of a triangle. How many congruent triangles are in a pentagon? 5. So you find the area of one triangle, you can multiply it by 5 and you have the area of the whole pentagon. Right? So let's look at what that looks like. Just watch this. Don't write this down yet, please. Just watch this. Here's the triangle. This is triangle ABC, and we have sides X, Y, and Z. How do you calculate the area of a triangle? 1/2 base times height. Right? Now, in these problems, you're not going to get an H value. Right? It's not going to give you H. You're only going to have all the exterior lines. So I need to somehow figure out what H is equal to. Well, the sine of A is equal to opposite over hypotenuse, right? Well, I'm going to move the X over here. X sine A equals H. What does H equal?
X sine A.
So 1/2 of Y times x times the sine of a. Now look at what that means, right? It looks confusing, but it's visually easy. 1/2 times x times y times the sine of the angle between them. We'll calculate the area of that entire triangle. Merry Christmas. You guys are looking at me like I don't know. Actually, I was expecting like cheering and. Okay, let's just try it. To calculate the area of this triangle, watch, just watch. 1/2 times 6 times 4. Why have we never used this before? Because every triangle I gave you looked like this. Was there any interior angle measurements there? No, but now I'm giving you an angle measurement. So the area of this triangle, 1/2 times 6 times 4 times the sine of 68. 11.12. Now, do you see visually what's going on? 1/2 times 6 times 4 times the sine of the angle between them. Can you wrap your head around that?
Yes.
If you don't remember this, it's a burden and it's not a gift. The intention is that this is a gift. Let's try another one. Write it down, please. One half times the side length times the side length times the angle, the sine of the angle sandwiched between them. Is it that bad? No. Not really. Anybody have any questions or thoughts? Or the only way that I ever baker this and make a small mistake is sometimes I neglect to put sine in there. I don't know why, I just get in too big of a hurry. It's always 1/2 length times the sine of the angle between them. Did anybody calculate it?
35.9.
36.
36-ish inches squared.
So it doesn't matter which side was
It does not matter. What will not work, I'll use that on the next example. Let's say that that this was 10. So when I add an extra number there, you can only use two numbers. You can only use 8 and 4.5 because you know the 99 is between those angles. You can't do 1/2 of 8 times 10 times 99 because the angle is not between the two sides that you're using. The angle has to be included in the side lengths that you're using. All right? Now, here's the gift. You ready? I want you to watch with your ojos real quick. Let's go back in time. Look at this figure. Now, inside of every pentagon, 5 sides, how big is one central angle? Central angle. 360 divided by 5. So I have a triangle at the base that looks like this, 72. How long is this radius? How long is this radius? Huh. Can you use the gift that I just gave you to calculate the area of that pentagon? 1/2 times 10 times 10 times the sine of 72. How many of those triangles are in that freaking pentagon?
5.
All that times 5 equal triangles. Let's try it. 1/2 times 10 times 10 times the sine of 72 And please give me 5 of those triangles. Boom! Mic drop. You're welcome.
Thank you.
It's either a gift or it's a burden. You can use 1/2 the apothem times the perimeter, or you can use Baker's little sneaky way using trig to find area to find the area of a triangle and multiply it by 5 congruent triangles in the shape. Okay? So now that you have options, let's calculate the area of this hexagon. So, again, 6 sides. So that means that the measure of the central angle is 60. Student justifies that the length of this red line is
9. 1/2 sine of 60 times 6.
because there's 6 congruent triangles in there. That makes me happy. Does anybody enjoy this more than the other method?
Yes.
Right? Will it always work? It's important to know when this will fail. Okay? Can you use that here?
No.
Why not?
Because it's not
Because we
valid.
already
You don't have a radius. So if you're going to go ahead and trig to find a radius, you might as well just go ahead and trig to find the side length. It doesn't really matter, does it? Here will it work? Unfortunately not. If you're going to trig to find an apothem, you might as well just find the apothem instead of finding a radius. So it will work when you're given a radius. When you're not given a radius, it will not work. Alright? It will work here. Well, there's a lot of different things that'll work here. How many degrees is one central angle?
120.
120. But it creates a 60, 30. So you could use special right triangle trigs. You can use trig to find the apothem. You can use that 1/2 r times the sine of the included angle. There's a lot of different things you can do here. No matter which way, it works. What do you think's the fastest way? 1/2 base times height. That's probably the
Well,
most complex way to do this problem.
Well, if like we had the height. 1/2 times 6 times 6 times sine
How many of those triangles are in there?
of 3.
So that way we work 46.7. 3. Special right triangle tricks. 1/2 the apothem times the perimeter. 0.5 times 3 times, what did I say? 18 square roots of 3. So many different ways to do it. I think in my case, for me, as an adult that's done this a while, that the special right triangle tricks are faster. You guys are probably more comfortable using than what you just learned. Alright, so all that stuff is great. So let me stop this.